did basically is everything that doesn't look like Android because it has some kind of low-level driver that is not common on phones. We try to abstract it in a way that doesn't look unnatural to you. So this is how it looks like to move the car forward. This is what you write. And if you look, this is a standard Android code. You basically have an override for a listener. Basically, you have the same structure that you use for a button click. You have for a button click on your remote controller. And what it does is it tells you which button the user clicked. And based on which button the user clicked, you have a method called move forward that knows exactly what to do, which is to set a speed forward on all four wheels to a number 255, which is the maximum speed. But you don't need to know any of that. You just call a function called move forward and the car is moving forward. You want to customize this because you want your car to move forward in a different way, you can totally do that. You can implement your own method. You can just copy the code from the default and implement your own. But as you see, this doesn't look like robotics or hardware or something foreign if you have done Android before. And so these are the kind of libraries that we provide with the project. There are two more things I want to show you that are a bit unique about this project. The part about autonomous driving. So we also provide computer vision software and TensorFlow for machine learning. So this is the computer vision part. This is all the methods and functions that you're gonna want to use to process the images that you're taking with the camera. So basically, autonomous driving using computer vision means you're gonna take pictures of what is in front of you. You're gonna try to understand what's in there. And based on what you think you see, you're gonna take a decision. Do I need to make a left? Do I need to make a right? Do I need to slow down? Do I need to move faster? How does that work? Bunch of transformations. There is like a bunch of things that you do to your images. Let's say that this is what you see on your car while driving. And this is exactly the same example for the RoboCar, right? You have a picture in front of you. This is what you see. So one of the first things you want to do is you want to reduce the data that you have in that image. You don't want high resolution images for at least a project like this, because what you're interested in is in the main things. In this case, what we want to know is where the lanes are. We want to make our car to stay on track. We don't care about trees, about pedestrians, about other cars, because this is basically we are interested about being in an indoor track, right? If you are building a real world car, for sure, you want to have 10 more cameras that each one is dedicated to one of these things that we are ignoring here. But because we are learning, we can focus on the basics. So what you're going to do is regular 5 megapixels Raspberry Pi off-the-shelf camera. You make it black and white. You even blur it to reduce some of the noise. So you still see where the lanes are, but we have just reduced a lot of information out of it. And what this means is that now the processing is going to be much faster, so you can do it almost real time. The more pictures you take, the faster the processing is, the more data you have to tell your car what to do. So sometimes, if you see these cars driving, and there are plenty of videos on YouTube, sometimes you see that they arrive to a turn and they take the turn too late. And what happened there was that they knew the turn was coming, but because of the processing was so slow, that by the time that they realized they needed to make a left, it was already too late. So you want to accelerate that as much as you can. And we basically provide you like a pipeline of things that work, but you can basically enter any layers in there that you want. You can add more functions, remove some functions, reduce the resolution of the images. You can play with any of that. Next is apply something like a canny filter, is how it's called. And you see basically what we did there is after removing some of the information, now we have like the basic contours, the lines, the borders that are making that image up, right? With that, basically, we are in a position to start identifying what lanes are. And you would say that there are tons of false positives there. One thing you're gonna do is you're gonna mask those results. All of these are methods, are functions that are already pre-programmed with the project. You need to understand which computer vision library you need to include, or what are the parameters, or what are the gotchas of each one. We already have them all pre-made for you. And finally, and this is a really cool transformation that we'll provide, is the change of perspective. So this is the same camera that you had before, pointing forward. A camera that is pointing forward, you can do this computer vision transformation to make it look like you rotated 90 degrees and you're looking now at the road. And this is the same picture that we had before. So if you combine all these filters here, it will be very easy, and this is something the software does. You can do a histogram, and you know exactly what the two lanes are. You click, at this point, you know exactly if you need to continue straight, you need to make a left, right? And you can actually do an estimate of it's a left turn coming after that, or it's a right turn coming after that. So these are the kind of things that the library will do for you, and eventually, this is the kind of pictures that you see. You're driving, you see lanes, you're on your tracks, and you know exactly what you're supposed to be driving. You know if you need to make a left, you know if you need to reorientate yourself because suddenly you are too close to an edge. And this is kind of information this is what the car sees. This is the computer vision approach. As you see, it's like a bunch of like little transformations that help you understand what's in front of you. And it's very visual, right? It's very easy to understand what's going on here. Some of the filters are a bit sophisticated, but basically you understand what's going on. Then the magic happens. You can also ignore everything I just said and say, I'm not going to use computer vision. I'm just going to use TensorFlow. I'm just going to use machine learning. And I'm pretty sure that you have read about machine learning already. Basically, the way this works is, okay,